Okay, now, okay, okay, now we're going to talk about voltage drop on the high side. Now, the purpose you do a voltage drop, it checks for resistance. If you have excessive resistance either on the voltage side slash aka feed side or the ground side, it will affect that component. For example, a voltage drop checks for resistance. Unwanted resistance, you lose voltage. When you lose voltage, that component either going to be dim or does not move or does not spin like it's supposed to. A good example would be a starter. Everybody thinks a starter when they, not everybody, it happened to me. When you turn the key and it clicks, click, click, you turn the key, click, click, tap on it, click. Oh, you got a bad starter. Been there, done that. Change the starter, click, 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 nothing. What the hell is going on? You look at the battery's fine. Again, it happened to me years ago. Alright. You do a voltage drop on that cable or that connection between the post and the cable and you see 4 volts, guess what? That starter's not spinning. A voltage drop checks for resistance. Any unwanted resistance will cause a light to go dim or a load like a starter to spin slower. Now look at this page here, this slide. High side voltage drop, testing the component voltage drop on the high side, it means the feed side. Now you gotta understand how they doing this. Trust me, you need to understand this. Right now, they're using a lab scope, not a voltmeter. And one thing I forgot to say on the last slide, when it comes to lab scopes, digital storage oscilloscopes, same thing. A lab scope is just a voltmeter, but you just see a painting of the voltage, a representation of a voltage drawn across time. That's what you're looking at. Here we see a lab scope. I know you can't see the numbers yet, but look at this. 100 millivolts per division. We remember last time voltage from bottom up, vertical voltage, time left right, horizontal. Okay, I'm going to start here at 0, 100 millivolts, 100, 200, 300, 400, 500, 600 millivolts. This line, when you connect across this relay, main relay, is showing you 100, let me see, 200. No, I said that wrong. 100, 200. So it's showing you, this is 100. So I'm showing you about 500 millivolts. Alright, so it's 0, 1, 2, 3, 4, 5, 6, 7. So 0 here, 0, this division to this division is 1. I'm in the middle, so it's about 500 millivolts. A contact right here should read no more than 3/10 of a volt, 300 millivolts. Remember how you move the decimal? Alright? So it's a little over. Now how you know I'm checking the contact? Just like a voltmeter, when you do a voltage drop, lab scope the same way. I'm checking what's in between the leads. I got my positive lead here and my negative lead here. The only thing between those two leads that's activating is the contacts. So in theory, a contact should be no more than 3/10, 300 millivolts. 500 millivolts is a little corrosion between those contacts. Let's look on this side. Fuel pump relay. Again, what's in between the leads? Positive, negative, activated circuit. Current has to be flowing for this to work. I'm reading 1, 2, 3, 4, 5, 600 millivolts. I'm in between it, so I'm about 550 millivolts. A little higher on contacts. So, even though it's not that bad, it's about a 1 volt, 500, yeah, it's about 1,000, about 1 volt drop between battery and here because of the contacts on the positive side. That means if this fuel pump is supposed to be getting 12 volts, I'm now running on 11. If there was a light, it would be dim. So voltage drop checks for the resistance. Understand that. I'm doing a voltage drop on the feed side. Feed side means hot, positive. Here, hot. This whole side is hot. This side is ground. We're not on this side, we're on this side. This whole side here is hot. I'm losing 1 volt. So if that was a light, which is not, it would be dim. If it was a motor like it is, it's slow. It'll move slower. If it's a fuel pump, it will be less fuel volume and could cause the car to have a high-speed hesitation. Here's a circuit voltage drop again. Now, on the feed side, positive lead here, negative lead here. See, negative, positive. Positive lead to closer to the positive source. My negative lead to least positive, which is over here. I'm reading about 200 millivolts. Alright, it's a little high also. Over here, I got a resistor in between here and here. I'm gonna be a little higher. 1, 2, 3, 4. 300 millivolts. Now, if that was just a cable, let's go back to here. See, if that was just a cable like this, and I did the same test from here, imagine that wasn't there. Imagine that was a connector. I go from positive to least positive. I'm reading 300 millivolts on a clear wire or a connector. That would be bad. 300 millivolts is resistance. The same thing here. Positive to the positive coming out the relay to the least positive, to the feed side. Now I'm reading a little over 200 millivolts. Maybe, well, no, not even 200 millivolts. This is 100 right here. That's like 50 millivolts here. I'm sorry, 50 millivolts here. 0, 0, that's about 50 millivolts. That's good. So it's 50 millivolts on this one, 50 millivolts on this one. This one's 300 millivolts. This circuit has a problem. I think I said this one wrong earlier. I might have said 100. That's 50 millivolts here, 50 millivolts here. This one's about 300 millivolts. Here I would have a problem. Now, a high voltage drop checks for resistance. That means I have resistance, as you can see here, in between here and here. But if I had this circuit and did that same test between here and here and read 300 millivolts, this wire could be bad. If there was a connector there, the connector could be bad. Now, we're going ground to ground. There's a voltage drop on the ground side now. See, this is a ground terminal. Ground to ground. 100 millivolts per division. And now, here's a hint. On the ground side, it should be no more than 1/10 of a volt. 100 millivolts. We have 100, 2, 3, 4, 5, 6. 550 millivolt drop on the ground side. That means I'm gonna need some voltage to get the current back to ground. So I'm gonna have to take it away from this load device. Again, the load will not run like it's supposed to or designed. If it's a light, it'll be dim. And also keep in mind, I think I said this to make sure I said it. See the switch is closed. You cannot do a voltage drop. You cannot do a voltage drop unless there's current running through that circuit. There has to be current running through the circuit for this to work. Okay, hope you understand that. Peace.